Okay, another bit of core knowledge you really need to have. There's a difference between elements, compounds, and mixtures. So, finished the last video talking about this idea of elements. These are pure substances. Elements are just one type of atom. So, I think I suggest this could be a bit of diamond. It's not quite true because I need to see some cross-linkage. But these would all be carbon atoms, all joined together. So I've shown the linkage. But most things don't exist in pure form. And they don't because they end up combining with other things. So we have here 3 different models of what water might look like. We know that there are 2 hydrogens, H for hydrogen, and 1 oxygen atom. And researchers discovered that the angle between the 2 hydrogens is 104.45 degrees, believe it or not. And the distance between oxygen and hydrogen is 95.84 pms. And I'm now trying to remember what pms are. Picoseconds, maybe? Really small distance. But we can measure these things using electron microscopes and things, and studying the crystals of objects. In fact, Dr. Nemkovic did that sort of work for her PhD. But there are also other models. This model here is just showing how this thing takes up space. So there's our oxygen, red, and our hydrogens, 2 white ones. And this one sort of gives that indication of the shape using balls and sticks. We've got some balls and sticks. We might get to play with those. Modelling things is quite fun. So, compounds. These are substances that have 2 or more atoms involved. Clearly water, pretty simple. Carbon dioxide, also pretty simple. 1 carbon, 2 oxygens. But it tells us about how these things stick together, what products they've got. It's interesting how they change state. Remember, hydrogen exists naturally as a gas. Oxygen exists naturally as a gas. But when we make H2O, we end up with a liquid. We get water, so it changes their state. So there's a lot we can learn from what happens in compounds when things mix together. And the other important thing is this is a formula, H2O, CO2. That formula is quite important when we compare these to mixtures. So here's, I think I used cake last time, didn't I? This one's a lovely, healthy salad. But again, it's a mixture. It's stuff thrown together. There's a tomato, there's some onion, get a couple of different lettuce leaves. So it's a very nice looking salad. Could do with a bit of cheese and maybe some nice dark olives would go well. Anyway, there's no formula. It's just stuff thrown together. You've got a recipe, and you may have chosen certain things to fit together because they taste nicely together, but there's no formula to it. You can't say lettuce 2, tomato 1 sort of thing. It doesn't quite make sense the same way. And we can pull this apart. Really easily pull these things apart. With our water, you can pull water apart and get oxygen and hydrogen again, but it takes a lot of energy. If we get a chance, we might even do that experiment. We have got the voltmeter for that purpose. And that was a very simple little video on elements, compounds, mixtures. 3 really important terms to keep in mind.